category of elements that we can actually talk about again are the what? Are the non-metals. The non-metals, those are purely elements that does not have metallic properties, such as what? Metallic luster, such as brittleness, such as malleability. Malleability is the ability of an element to be beaten into sheets, such as ductility. When an element is ductile, it has ductility property. It means that what? It can be what? It can be drawn into wire, such as what? Such as copper, such as what? Such as silver, and some other metals. Now, non-metals, bunch of non-metals, bunch of them are actually gases, and majority of them can be seen in group 5, 6, 7, 8. In fact, all the elements in group 8 are gases. So, nitrogen is a non-metal. Phosphorus is a non-metal. All of these are gases. Oxygen, sulfur, gases. Fluorine, chlorine, bromine, all halogens. Group 7 elements are called what? The halogens. So non-metals, actually, non-metal houses, the chalcogens. The chalcogens are the group 6 elements. The chalcogens. That is the what? The group of oxygen. Oxygen, sulfur, selenium, tellurium, polonium. Those are the what? Those are the chalcogens. Then non-metals also houses the what? The halogens. The halogens are the what? Are the group 7 elements. Why non-metals as well houses what? The group 8 elements, which we call the what? The noble gases. The noble gases. They are the group 8 elements from helium, neon, argon, krypton, xenon, radon. Those are the what? Those are the noble gases. The noble gases in the past have been given a lot of names that were nullified by scientists before noble gases were actually given to them. In the first place, they call them group 0 elements. They said they are group 0. In some periodic table, you will see 8 to the what? To be written as 0. You can call them group 0, and you can call them what? Group 8 elements. Also, another name, they said that name is not befitting enough. They come with another name. They call them rare gases. They said, okay, don't let us call them group 8 or group 0. Let us be calling them rare gases. Because most, not all actually, of the elements in group 8 are what? Are rare. But it has now come to the notice of scientists that argon is a gas that is very much present in the what? In the atmosphere. Argon is present very much in the atmosphere. Okay? They said, okay, because argon has nullified that name, okay, let us cancel that name. Then I call them another name. Okay, what else can we call them? Okay, let's call them inert gases. Okay, this is actually what we are saying. First of all, they said group 0 or group 8. Okay, let us call them rare gases. And argon actually nullified that. No, they are not rare. Argon is very much present. Okay, now let us call them inert gases. By the time they give them inert gases, science also evolves. And they actually came about that xenon, when you bombard xenon very well, by bombardment of xenon very well with chlorine gases, we actually see that we can actually have xenon tetrafluoride, which means xenon can actually also react under an extreme condition. So we said, okay, they are not inert, because the meaning of inert means that they cannot react. They have actually what? Completed their what? Their octet shell. We will come to octet shell and the like when we start with the electronic configuration. How are the electrons of these elements are being configured? How are the electrons of this element are being configured in such a way that reactions can take place? Because chemistry is actually reaction. Chemistry is actually reaction. Now xenon. Xenon is not inert. Xenon is not inert, so they nullify the name. And we now come up with noble gases. So okay, they are noble. Because all elements in the periodic table, don't let me lie to you, all elements in the periodic table are actually striving. They are actually striving to become like noble gases. They actually want, that is the basis of chemical reactions. For example, sodium is very close to neon. Sodium is very close to neon. So sodium will be striving to become like neon. That is what brings about the fact that sodium will want to lose one of its electrons just to become like neon. So all elements in the periodic table actually react in order to become a noble element, just to become like noble gases. That is why we say, okay, noble gases befit them. So they are called noble gases. Fantastic. Now don't forget we said there are 7 main categories, and we are in number 4 already. Okay, 5. We have the transition elements. We have the transition elements. In this tutorial, I will only list the first transition elements. The first transition element. The transition elements are elements that occupies the center of the periodic table. They occupy the center. Okay. They actually have 10 colors. Okay, after calcium. Wow. After calcium. What can be done now? Okay, let's just do it like this. Let's have it like this. Fine. After calcium, we have scandium, vanadium, titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the first transition elements. Don't forget, I said they have 10 groups. 8, 9, 10. Scandium is number 21. White zinc is number 30 in the periodic table of elements. So from scandium to zinc, that is the what? First transition element. All transition elements are metals. All transition elements are metals. Transition elements are very, very important Very, very important, because if there are no transition elements, there is nothing that we call complexes. They are not, they form complexes. The transition elements form complexes. They are colored elements, and they are very, very important. In actual fact, the copper that we use to generate electricity, copper is a transition element, as you can see. Copper is number 29 of the periodic table. Gold, silver, they are all what? They are all transition elements. Mercury is what? Is a liquid, but it is a metal. Mercury is a liquid at room temperature. But at a particular temperature, mercury is what? It's actually a what? A solid. It's a metal. Now, these are the transition elements. And the next two categories, in which I will not bother myself on it for now, are the what? We have the actinides and the lanthanides. The lanthanides and the actinides. Those are the elements that actually we have 14 groups of them. That occupies the bottom of the periodic table. They were brought out from the periodic table from lanthanum. The lanthanide consists from lanthanum. From lanthanum to what? To lutetium. And so on and so forth. So, this is 7. So, we have 7 main categories of elements. And in actual facts, we have 4 groups, 4 blocks of elements in the periodic table. We have 4 blocks of elements in the periodic table. Which are the what? Which are the S, P, D, F blocks. Which are the S, P, D, and F blocks. The S block consists of what? Of group 1 and group 2. Those are the S block. Then the P block consists of group 3 to 8. The P block, majority of them are non-metals. Why the D block? The D block are the what? Are the transition elements. The D block are the what? Are the transition elements. Why the F block? I said they occupy the what? The bottom of the periodic table. And okay, there are 2 main groups like this. I'm not going to draw them. So they are the F block. From lanthanum to lutetium. Why lanthanum is actually number 57. Lutetium is 71. Why these are the lanthanum, the lanthanides, these are the lanthanides. The actinides is from actinum. Actinum is 89. From actinum to what? To lawrencium. Those are the F block of elements. So in the periodic table, we have 4 blocks. S, P, D, F block of elements. Thank you.